All right, so yesterday we looked at, or I should say Tuesday, we looked at the binomial theorem. And I told you on Tuesday that this was the key term. If you're going to memorize anything, memorize this term, NCR times x to the n minus r times y to the r. Okay? N choose r times x to the n minus r times y to the r. And the reason for this is because if we're looking at an expansion like 2x minus 3 to the fourth, there are a couple of things that we could do other than just ask you to expand the whole thing. All right, for example, we might ask something like this. What is the fourth term? Okay? We don't want you to expand the whole thing out. We just want the fourth term. We might also ask a question like this. What term has an x squared in it? Okay? Make that an x squared. Okay? What term has an x squared in it? And again, we don't want to have to expand the entire thing out. Even though this one's just to the fourth power, it wouldn't take too much work to expand it all out, but we don't want to do more work than we have to. So, let's look at how we would go about answering these questions. Okay? First of all, if you think about the terms in our expansion, the key to figuring out the term really is figuring out what r equals for that term. Okay? Put the laptops away and focus, please. Now, if you notice, our general or our pattern here has y to the r. What is y2 in the first term? What power is y2 right here?
Oh, 0.
0. Okay, so it starts at 0, goes up to whatever r is. Okay? So, if I'm at the fourth term, okay, what is the power of r going to be there?
3.
It's going to be 3. Okay, because we started at 0, 1, 2, 3. Okay? But that'll be our fourth term, 0, 1, 2, 3. All right, so now I know that r is 3. It's always 1 less than the term. Okay? It's always 1 less than the term. Again, because you start counting at when r is 0. So now when we're trying to set up our term, I know n equals what for this expansion? 4. Good. N is 4. So I have 4, choose 3. Then I have my two terms. I have 2x that's raised to some power, and I have the negative 3 that's raised to the r power, and we know r is 3. So we automatically know 2x is raised to the, which power? Yeah, the first power, the 1. Okay, because remember it's n minus r. 4 minus 3 would be 1. Now we have it, and all we have to do is evaluate. Okay? Are there any questions?
So you just multiply that and your answer?
Yeah, we just multiply this out now. What's 4 choose 3? 4. Good. Good. So that's 4 times 2x times a negative 27. You figure that out, and that's a negative 216x. All right? So that is the fourth term.
So basically you'd expand using binomial theorem by doing that for every single term.
Yeah. Yeah. Now, when you are expanding the whole thing, you can kind of use the pattern, you know, to kind of make it a little bit simpler, but this is essentially what you're doing for each term. And obviously that's a lot of work, and if we can avoid doing all of that, when all we need is the fourth term, then let's avoid doing all the work. Okay, yes?
Where'd you get the 4 when you multiply 4 times 2x times -27?
That is the 4 choose 3. Okay? 4 choose 3 equals 4. Okay? By the way, as far as, I mean, you're not going to have to memorize values for combinations, but a couple that are kind of the easy ones, if you, we'll use 4 for an example. 4 choose 0 and 4 choose 4 both equal 1. Alright, those are both 1. The next one in from the ends on Pascal's triangle is 4 choose 1 and 4 choose 3. Okay? Well, how many ways can you pick one thing out of 4? 4 ways, right? Well, think about this. If I'm choosing 3, that's the same as picking 1 to leave out, right? That's the same thing, logically. I'm either picking 1 to include or 1 to leave out. So what's the value of 4 choose 3? 4. Okay? I get the same value for both. Keeping an eye on those, that'll kind of minimize how many you actually have to evaluate out with the factorials or with your calculator. Okay? So, you'll save yourself some time.
Can you scroll back up for a second?
Yep. Now, to answer the question, what term has an x squared in it, we need to realize what we're actually given here. Okay? Now, using this, since this is x, and that was the fourth term, x squared is going to be the third term, but let's assume that we don't know that to begin with. If we're told x is squared, what value are they giving us in this, pattern up here? Whoops. X is to the second power. Yes, there you go. That's kind of the key there. Since x is squared, you know that entire term, that entire part 2x must have been squared, right? So that is this right here. Okay? Once you recognize that, everything else is somewhat easy. We have 4 choose r, and we have -3 to the r, okay? Now, if this is n minus r, which equals 2, what does r have to be? It has to be 2, because n is 4, 4 minus 2 would give us 2. So now, I know that's a 2, and I know that's a 2. Okay? Because n minus r equaled 2, and that's 4 minus r, which equaled 2. So r is 2. Does that make sense?
Yeah.
It's kind of like a little bit of a puzzle. You got to look at what you're given, what that tells you, and then figure out the rest from there. Okay? Once we have this, then we can figure out everything. 4 choose 2 equals 6. This is a 4x squared. And then this is a positive 9. We multiply that all out. And I think that was a positive 216, if I remember right, x squared. Okay? So here we're getting specific terms, not the entire expansion. Okay? Now, here, just to confirm that, notice our term with the x squared was positive 216x squared. And the 1, 2, 3, the fourth term is negative 216x, just like we found. But we didn't have to see the whole expansion to do it. Okay? Also, one thing that we recognized when we were doing this fourth term, the term number is going to be one more than whatever r is, because you start counting at 0. Okay? So, you start counting terms when r is 0, so it's always one more. Okay? So, let's try one here, and I'll warn you, you're going to get a very big number, so that's okay. It's like in the trillions. But let's say we only wanted the 17th term of the expansion, 3x plus 2 to the 20th. Okay? The 17th term. So just so we're all off on the right foot, what does r equal? 16. Alright? So take it from there and see if you can't find the term. And it's okay to have scientific notation. This here is what your calculator uses. Go ahead and write times 10 to the 10. Okay. In physics, they let you write just E. Okay. I will tell you yeah, I would like you to write times 10 to the, especially as you go, yeah, especially as you go forward in math. No, in math class, they're never going to let you, like, whether you do AP or IB or whatever, they're not going to, that's not going to fly.
I usually do it.
That should be the 16. Yeah. Yeah, the term number is always one more than R. Remember, R goes with the second one, so these should be switched. Yeah. You can write it. Yeah, what you have is fine. Yes. Well, that's scientific notation, okay? Now, you can write out, if you actually count, there's 9 digits. So if you put a 0 on and wrote it all as one big number, that's fine without scientific notation. Or if you just put like 2.57 times 10 to the 10 times x to the 4, that's okay too. Oh, if you go to, well, first of all, you'll punch in the n, so 20, and then if you go to math, all the way over to probability, choose number 3, and then you type in the R afterwards. Okay? All right, so from what I'm seeing, you guys are setting it up well. All right, it's 20, choose 16, and then we have 3x, and we have 2. The 2 is to the 16th, the 3x is to the 4th, all right? And then you have to multiply that all out. All right, so let's bring up the calculator just so we can see. If you have a TI-30 or something, that's going to be a little bit different, although the TI-30, if you have the 2-line display ones, there's a PRB button, all right? If you hit that, you'll see the combination and permutation in the factorial. Are you going to join us? Come on. But I'm going to show you how to do this on the TI-83, which is exactly the same as the 84. If it ever decides to open up for me. There we go. All right, so if I'm doing 20, choose 16, I'm going to type in n first, and then if you go to math, you'll notice we have math, numbers, complex, and probability. Okay? Number 3 is NCR. So if you just choose that one, and now we want 20, choose 16, so we type in the R, and that tells us it's 4,845. Okay? Now, does this mean you don't have to know the formula anymore? No. Okay? I still might ask you, hey, evaluate this combination by hand, all right, by reducing the factorials and so on. All right, but if you're then doing a problem like this, where I don't ask you, all right, you would just show what I have written here, and then you can do the combination on the calculator, all right? So here we have 4,845 times 3 to the 4th is 81, x to the 4th times 2 to the 16th power.
65,536.
All right. Okay. So then you would need to multiply this all together. So that times 81 times 2 to the 16th is faster. There we go. And you get that. Okay? Now, evidently, if you're in physics, they don't mind if you put E. Okay? In math class, we don't put E. That's scientific notation. All right? And whether you go to IB or AP, they're not going to let you just put E down. All right, so you need to translate this. So you have a couple of options. One, you could write it down just like you see, 2.5719275552 times 10 to the 10th power x to the 4th. All right? I'm not going to complain about that. All right? The other possibility would be to round the scientific notation and just say that it's 2.57 or even 2.572 times 10 to the 10th x to the 4th. Okay? One other possibility, this is probably the least preferable one. You could say it's approximately, and just, we're only one digit short of having the full 10 to the 10th. So you could put 25719275520. Alright, we're up over 25 trillion x to the 4th. Okay? That's okay. That would be correct rounded to the nearest 10. Alright, because we don't know what the next decimal point is in this. Alright. This would probably be the best answer, though. Okay, yeah.
So when you're fighting, you also have to multiply the numbers by NCR? Like,
Yes, when you figure these numbers out, you do need to multiply them by that coefficient. Okay. Okay. Any other questions?
The reason you need to multiply by the coefficient becomes really obvious when you look at a probability example. So for right now, just believe that you have to do it.
I was just double checking.
Yeah. And that we're going to get into in our next unit when we do probability and statistics. We're going to look at the binomial probability theorem, which is basically the same thing, just in a slightly different context. Okay? All right. So, let's try a couple of these. You can work with a partner. Here are two. Find the sixth term of a plus 2b to the 8th power. And then here's another one. Find the coefficient of the term a to the 6th, b to the 5th in the expansion of 2a minus 5b to the 11th. Okay? So take a few minutes, work with a partner if you like. You can move the desk over if you want. Alright, but let's go ahead and see how you guys can do with these.
Yes, it wouldn't matter. This number always has to match this.
This started off as right, so you go down.
That one, I think, that one was, I think you lost a number in there. So I'm remembering a bigger number. Hey, real quick, what did you get for the sixth term?
1796.
Let's real quickly here. 8 choose 5. A to the third, 2b to the fifth, right? What does that equal?
1792, A to the third,
Did others get the same thing?
B to the fifth.
B to the fifth. All right, thank you.
Wait, what was the?
I got 896.
What was 8 choose 5?
8 choose 5, 876 over 6, so 8 times 7 would be 56. Okay. Then this one, you would have had 11 choose 5, because B is to the 5th, and minus 5B is to the 5th, the 2A is to the 6th power then, okay? And it asked for just the coefficient, so you only needed the number, and it was a negative 92,400,000. That sounds right. There we go. Okay? So, do some practice with it, with the independent practice, and we'll see you tomorrow. All right? Have a great day.